You're not going to want to miss the next couple episodes of the AI show where I take you inside a talk I did at the Toronto AI user group. These bite-sized chunks will talk all about what AI is, how machine learning works, and maybe even a little bit about deep learning. Get into it, understand it. Make sure you tune in. How's it going, everybody? I am Seth, and our org is different than all the other ones because I am not here to sell products. I'm here to solve problems. Do you like the alliteration on that? Solve problems, right? So basically, what I'm going to do is this is an introduction to deep learning, but my sense is that all of you know a lot of stuff, so I will go fast or slow depending on what's going on because I have put way too much stuff in here. Basically, I'm going to motivate convolutional neural networks from first principles, and then show you what it looks like in TensorFlow, because you probably all know what it looks like, and then show you how to run it on Azure, basically. Okay, and so obviously that sounds like a lot of stuff, because it is. And so I will go fast or slow depending on what you tell me to do. And so since Canadians are super nice, you can basically just be like, and I'll be like, okay, I'll or be like, and I'll know, okay, in your nice way. And you won't have to say sorry for it afterwards, okay? Just FYI. So the thing about machine learning and deep learning, and since you are all, I'm assuming, practitioners, and if you're a beginner, that's okay too. This is for everybody. The thing with machine learning is we have this kind of super huge gap of understanding to overcome because terrible things have been done with AI and machine learning, right? Come on, that's funny, right? Is it Clippy? They're all looking at me. These are the jokes, people, okay? And the thing about it is that everyone today is all about machine learning or deep learning, right? And as you know, the difference between machine learning and deep learning depends on the marketing guy, effectively, right? And so that's the important thing. And the reality of the matter is when I explain it to people, let's just say, because I'm assuming you all know this stuff, but this is how I explain it to people so that if you ever need to, I always say, look, you know, when we're talking about AI, it means a lot of other things too. If you remember, like way back in the day when the Deep Blue chess thing beat Kasparov, that's AI. But it's not machine learning. And it's very important to distinguish, right? And the way I like to think about it is the search space. The size of the search space kind of helps you know where things are. Like the search space in chess, while large, is still finite. The search space in the amount of pictures that people generate is infinite. Because I have seen some crazy stuff on Twitter, right? And you know this. And then our parents put really crazy pictures on Facebook, right? So what is the difference between artificial intelligence and machine learning, right? In my professional opinion, artificial intelligence is a glorified search problem, right? You remember algorithms like A star, Minimax, they're all searching in trees with a good strategy. And this is how I like to think of AI, and I like to think of it as the hard part of AI, where there is a fixed problem space, right? When it comes to machine learning, there's a little bit of squishiness about the problem. And instead of searching a space, what we are doing instead is providing examples to generate an algorithm, right? And most people don't like this, because when I say algorithm, I mean model. We're building a machine learning model. But if you think about it, it's just a different way of making a function. It just looks weirder, right? And if you open like an HDF5 file in front of people that have never done machine learning, they think the machine's going to explode and glitter's going to come out, right? Because it's AI, but it's the file. And I say, well, it's basically a bag of numbers in a network. Sorry, right? Sorry to disappoint you, Steve, from marketing, right? It's not any more than that. It's a function that's written with data. So then what's the difference between machine learning and deep learning? Because some will tell you that neural networks belong in the space of machine learning, right? But then if you get to n number of layers, then it becomes deep learning. It is still an open question what that number n is. Again, it depends on the marketing people, in my opinion. Right, because you've seen ResNets. I think, how high do they go? They go pretty high now. ResNet. I'm a computer vision guy, and so I think in terms of computer vision. But these things can get pretty deep, and they do some pretty amazing stuff. And then the question that I always get from business people is, well, when should I use it? And that's an important question, right? Because everyone's like, hey, you should use AI. Just use AI. And you're like, I don't think you know what this is. We're making a function in a different way, right? So the example that I like to give, and maybe this will be helpful to you when you talk to your management about what this can do, is the example of a check. Anyone work for a bank? Oh, did I just make the thing go away? The screen? You still good? You got my screen? Okay, good. So anyone work for a bank? Okay, there's always a couple of you. And the people that work for banks are like programmer saints because the kind of data they deal with is just, it should be on the Dirty Jobs show, right? Right? It's like they're using COBOL, and for some reason, Bill always puts the name in the age field, and COBOL lets you do that, right? And that's what they have to deal with. So imagine you work for a bank, and you show up one day, and the guy comes down and is like, we have a really good idea. We want you to write an algorithm that detects whether the pictures of the check from the users are upside down or not. That's an easy problem, because your bank is cheap, and all of your bank checks have a black stripe at the top. Can you solve that? You can. And you all know that you just sample 100 random pixels at the top, and if they're all black, good. If they're not, you switch. So you tell Steve from marketing, I can do this. It's going to take 6 hours. It's really going to take 3, but it's a lot of YouTube to watch. Right? Someone has to watch all that stuff. If little Billy wants to talk about his life, we need to listen. So you do this, and one day, and he comes back the next day and says, I have a really even better idea, and it's just this one thing. And anytime a non-technical person tells a technical person it's just this one thing, we have to sit down. Like, no one will go up to a civil engineer and be like, hey, just this one thing, turn the bridge upside down. But they will do that crap to us all the time, right? So he goes, just this one thing. The owner of the bank, Sally, loves her horses, and she wants a picture of her horse on the check. Just this one thing. Now, could you write an algorithm to solve that check upside down problem? You could. You would ask for the check. You would do the bunch of if statements, and you'd go home and take an extra long shower because you wrote that code. But it works. Now, imagine if you have to do this for any person, for any check, for any picture. Did you feel that gap as a programmer? You felt it, right? That's the gap where machine learning works. And that's how because programmers have this intuition about programming, and when you put that gap into their head, they're like, oh, I can't write that. No, you can't, but you can give the machine examples such that it can produce models for them, right? And that's how I explain that gap, because intuitively programmers will start to code in their head, black stripe at the top, horse has pixels over here, and I can fake that somehow, right? And I can do some transformations. But then when you say any picture, any check, any person, they can no longer do that, but they know that a computer must be able to somehow. And this is where we sort of say, there's where machine learning works. And that's how I explain it. Now, all of you know machine learning, and so I'm explaining it to you this way because you already know, but when I talk about it to people that don't know, I literally make programmers feel the pain in that gap, and that's where machine learning works. Because as you know, programming is we make a function, we give it some input and outcome answers. In machine learning, we swap that around. But we don't call it a function, we call it a model. We don't call it answers and input, we call it data in machine learning. Right? And this you all know, it's just a different way to think about it when you're explaining it to the programmers who don't appreciate the pain we go through every day. Like, if something works the first time, we're different. We know something's very wrong. Programmers are like, I'm a friggin' genius. And we're like, oh, something's terrible. How is this possible? But what goes in there? So again, what we're doing is we're making a function such that we can predict on the things that we're going to build, but it's not clear to some people what these things look like. To you it is, and so I'm going to go through an exercise to motivate from first principles how it works. And we're going to use images like this. Okay, they're very stupid. This is stupid, but we're going to build all the way up to convolutional neural networks from the bottom up. And if you want me to go faster, remember. Okay? So I am going to ask you to build a machine learning algorithm, and you wouldn't do this, that predicts whether these pictures are darker at the top or darker at the bottom. Okay? How would you do that as a regular programmer? By the way, this is what the data looks like. So for example, This one is darker at the top because there's the answer. This is darker at the bottom, and there's that first picture. How do you know this one's darker at the top? You can use your regular programmer lizard brain. And I used to teach high school, so awkward silence is only awkward for you. Every time it's like, well, that makes me feel awkward. Yeah, not me. Yes, what would you do? So the answer that he gave was add the top, add the bottom, and compare. Right? Easy. Some people were like, some other people who, because you all are smart, you would come up with this. Other people like take the average of the top and the average of the bottom, but as you know mathematically, it's two wasted divisions. Right? Easy. Now, what if I forced you, like to think of this intuition, add the top, add the bottom. What if I forced you to put it into something like this? Where I asked you to invent some magic W's such that when you multiplied all of the input values, you would get an answer that would say top or bottom. How would you do, what numbers would you put in for W's? Yes. 1, 1, 1 here, zeros, minus ones. That's super clever, right? Because it basically what it does is it adds the top, adds the bottom, negates one side, and then they fight. Because as I learned in 4th grade, and this has magically served me very well, there's no such thing as subtraction, only addition of negative numbers. Saved my life as a 3rd grader. I remember getting all the minuses and putting a plus and then a negative. I'm like, okay, I know how to do this. Right? And if you think about it, if it's more negative over here, right, than it is positive over here, the answer will be negative, we guess bottom. Otherwise, we guess top. Super easy. What if it's 0? They're the same. Flip a coin, right? And that's okay. Any questions about this? See, and this is where I'm tricking you. Because there's something hanging out over there that you should have all seen, right? This is supposed to be interactive. We're all friends here. Canadians are nice. What's the B? Great question. Well, what if we wanted to guess bottom, even though it's not darker on the top, but it's within a couple of shades? Like if it's dark enough, right? Then you add a negative number. Right? And what that does is it forces this to be more negative. But what if we want to do it to the top? Then we add a positive number, and all of a sudden, we're guessing a top. It's almost as if we're biasing our answer. And in machine learning, we're super clever. We call that the bias. Yeah, who knew? We're so clever. Right, this is simple, and you've all seen this, right, as a perceptron algorithm. It's the simplest thing, but it's basically a dot product of the two things. If it's negative, bottom, positive, we guess top. Now let's try it out, right? Clearly works. You can see bottom right, this number comes out to be 236, so we guess top. This number comes out to be minus 234, we guess bottom. Now, don't ever use machine learning for this problem. That's dumb. We wouldn't do that. So basically, and this is where everyone else in the universe except for you all gets surprised, I say that W you just invented is a machine learning model. Right? I know I'm trivializing our work, but it is. If you think about all the other machine learning models you build, it's just that, but more of them. What about top, middle, bottom? What if I wanted to guess? Well, you just make 3 of them. And now instead of a single vector, it becomes a matrix. Right? And we do what I like to call a Cookie Monster operator because I'm 5 years old. You take this thing, right? You turn it on its side and go num, num, num. Dot product 3 times gives you the answer. The one with the highest number is the one that's the darkest, right? And this is why me and Dave were talking earlier. That's why I hate when people say the output of models like this have a probability. Like, because we softmax over the end, and we're like, oh, this is it's not a probability. We're forcing everything to sum to 1 mathematically. And so we're just basically whatever line this dot product sends the most density to, whatever line of poo this is, the one that has the most in it is the one that's going to be closer to 1. But it sure as heck doesn't mean that this is 100% a cat, right? And so that's another thing that I like to put out there. Top, middle, bottom, it's now a matrix. What if we want to do digits? Can we do this with digits? Yeah. Usually we want something like int digit get picture. We totally can. The numbers are much bigger, but it's the same thing. Do you know if I run this on MNIST, I get 92% accuracy? What? Right? I'm using an atom optimizer, though, and I'm being clever about how I'm doing it. But if you run this stuff in TensorFlow, you'll get 92% accuracy on MNIST. Yeah. Just this. And it's the same thing that you were able to invent in your head, which is pretty cool. So how do we get all these W's and B's, though?